This is Brandon Jones with the University of Cincinnati and Northwestern University. This video is the third in a series where we are going to explore the use of Android Google Maps and the Android emulator. In this video, we are going to plot some markers on the map by using some existing JSON data. I've covered JSON in a previous video, but we'll do a quick recap of it here in this video. What we're going to do is we're going to capture some of the GPS information from a map like this. This is a map of plants that I've GPSed in central London. And we are going to provide that to an existing page where I can enter the latitude and longitude, and it will find plants within a certain radius of that latitude and longitude, and we are going to plug those in on the map. Now, this video might, this concept will probably take a few steps and might go beyond the first video, so we'll see. We might have a fourth version and a fifth version. We'll just see how things go. But first of all, we're starting with the same project we've been using on the other two videos, which is a project I've been using in my Android programming courses. We already have in there a network DAO. This is something that we can use to access things over the network. We also already have started a map of plants. So this map of plants creates the page that we're seeing right here, which is essentially a map with geography on it. And what we want to do is we want to put markers on that map. So what we need to do is we need to make a network call, and the network call is going to reach out and acquire this information from this JSON page. But one trick with Android, especially newer versions of Android, is that if we are doing a network call, it has to be in a separate thread, which means we need to gather an async task. We need to create an async task. An async task will allow us to thread up our application. That's one consideration. A second consideration is we also need to know our location, and that's something we haven't yet done in our map of plants. So we need to know what our location is, which means we need to use a location listener. And when we get our location, we also need to send a request out to our JSON URL to find plants that are near that location. So let's start by acquiring our current location. To acquire our location, we need a series of objects. One is a location request, where we say how frequently we want to update our location. Another thing is a location client. The location client uses this location request to access updates. And then what it can do is it can connect with a connection callback and connection failed listener, which will allow us to connect to the location client. Once we've done that, we can also associate with a location listener. A location listener is an interface with a method called onLocationChanged. And that onLocationChanged method will be invoked when our location is changed. Now that's a little bit tricky, because how do we know when our location is changed? Our location could change by millimeters, couldn't it? Well, that's what the location request is for. The location request says how frequently do we want to get location updates? How frequently do we want to get notified that our location has changed? We don't want to go too much. We don't want to ask for too much, because that does consume a lot of power, and that's going to show on our profile that we've consumed a lot of our power trying to get location updates. On the other hand, we don't want to go too short either. We don't want to update very infrequently. So there are several different levels of frequency that we can specify in the location request to say, let me know if the location has changed, and do I want to actually actively ask for location changes, or do I want to just listen to other applications on the phone that are also gathering location changes and maybe share some resources with them? So the location request sets our frequency. The connection callback and connection failed listener tells us whether or not we could connect to the location client. And the location client is what glues together the location request and a location listener, where the location listener will receive events when the location has changed. So a few more details on these listeners. Connection callbacks, on connection failed listener, location listener on my button location listener. So this is what we need to implement. So I'm going to go back to our map of plants activity. And what I'm going to do is I'm going to start by declaring a location request object, and we can make this static. So we will say private location request equals location request dot create. Okay, and then from here we can set an interval. Okay, set the desired interval for active location updates in milliseconds. So how often do we want to get updates? We'll set 5,000, which is 5 seconds. In the live plantplaces.com mobile app, I actually have it set to 60 seconds because I find when I'm GPSing, that's about the time that I spend walking from one tree or one plant to another, but that is configurable as well. So how long do we want updates? Okay. We're also going to say set fastest interval, which is the fastest interval, the fastest rate at which you can receive updates. Okay, set fastest interval, we'll say 16. The next one is very interesting. Set priority, okay, and then we're going to say location request, and we'll use a constant here. You see we have high accuracy, low power, no power. High accuracy, and of course these have descriptions that come along with them, so it's a good idea to look at those comments. The most accurate locations available. So that means we want very location updates, very frequent location updates, maybe for something like walking directions or driving directions, something like that. We also have balanced power and low power, which offer us location updates without as much frequency and without as much power usage. The one I find the most interesting is no power consumption. So what happens then is that our application is not asking for location updates, but if a different application asks for location updates, we can piggyback on that and get those updates. So there's no power used in our app because we're just reusing what a different app is using. We'll go ahead and say high accuracy because this is in a test environment. So take a look. Notice that location request, and I need to spell it right, location request is what says how frequently we want to have these updates, and we choose save. And now this is available to us. Now, one very important thing we want to keep in mind, we want to remember what the Android lifecycle looks like. We have created, started, resumed, paused, and stopped. I want to especially pay attention to the paused and the stopped. The paused means there's something blocking our screen, maybe with either a transparency or some kind of pop-up, and so our screen goes to a pause state. The stopped means the screen is completely obscured or the screen has gone to the background. In these two states, we do not want to receive location events because the user's not actively using our screen. So we want to be sure that we turn off location events in these states. So we want to turn location events back on when we leave these states. Notice that all arrows pointing to the resumed or visible state, which is the state where the user is using our application, go through the method called onResume. So all method calls that take us to that resumed state go through onResume. The only way we can leave that state is by going through onPause. So what we want to do to subscribe to location updates, we want to make sure that we override this onResume state. Okay, so I say onRE, and that's really all I need to type. Then a simple Control and Tab will override the onResume method. From this onResume method, we can invoke a method called setupLocationClient if required. If this looks familiar, this is very similar to something that's done in one of the map tutorials. I'm using a very simple model to what's used in the map tutorial. I'm just adding in the JSON query as well. So we're going to say create method setup location client if required. Now in this setup location client if required, we are going to initialize a location client variable. We also need to make that location client variable. So what I'm going to do is up here where I have my attributes or fields or member variables, whatever you call them, first I'm going to click my, correct my Google Map and mark it private. And then I'm going to say private location client, location client. Remember again, the location client is what glues together the parameters we set in the request with a location listener. Control-Shift-O, that will automatically organize imports, which takes care of that red line. Now, set up location client if desired. I'm going to say if location client equal null. Okay. Then we're going to instantiate a location client object and store it into our location client variable. Okay, location client equals new location client. Now, pause here because we see that we can't call it with an empty constructor. That's simply not an option. We can't call it with an empty constructor. So if I control space, it will tell us the options we do have. One is a context object, connection callbacks, on connection failed listener. So we have some interfaces that we're going to have to implement. Okay. Now the context is easy. The context is a reference to the current object, the object we're currently working in, which is simply this. Now what we have to do is we have to make some objects that satisfy the interface for connection callback and on connection failed listener. Those could be different classes or they could be the same. Okay? To satisfy those interfaces, what I can do is I can change my method signature of this class and I can add implements, which is the keyword we use when we want to implement an interface. Implements on connection failed listener. I want to make sure we choose the right one here. You know, I don't know which one. And after a quick second of research, it's Google Play Services client that we want to implement. Now, that's an interface. An interface has methods defined. And our class will not compile unless it implements those interface methods. So notice as soon as I do that my map of plants now has a red line, which is an easy fix. I can click on the map of plants, hold Control, press 1, and choose Add on Implemented Methods, and it will just temporarily make an unimplemented method, an empty method, a method without any implementation that we can go in and fill in later. Okay, on connection failed listener, and then we also want connection callbacks. Okay, connection callbacks, and once again, I'll choose the one in Google Play Services Client. Okay, and save. And once again, since I'm implementing an interface, I have to click on the map of plants, Control 1, Add on Implemented Methods. And now what I've done is I am implementing both methods from the two interfaces that I've just added to this class. With that now, I can pass the two other arguments to location client. Okay, once again, new, I'll do this just so we can see the documentation, new location client, this comma, let me try that one more time, new location client, and we need to pass in a context, which we already have, a connection callback, and an on connection failed listener. Okay, so we need to pass in 3 objects. It just so happens the object we're currently in, this map of plants class, when it's instantiated as an object, satisfies all 3 of those parameters. So this comma, this comma, this comma, terminate with a semicolon, save, and now it's time to smile, because we notice that our class no longer has any red lines, and at this point we have instantiated the location client. The next thing that we need to do then is we need to connect to the location client. And to connect to the location client, we can go back to our onResume method and simply say locationClient.connect. Now, what were those weird interfaces for? We had onConnected, onDisconnected, and onConnection failed. Those are called naturally in those different states. Once we connect, if we have a connection failure, and once we disconnect. So if we have a connection failure, that would be a good time to, at the very least, log something. Possibly also inform the user, hey, I can't connect to GPS. So that's when we want to kind of think of some error trapping. I'll leave that up to you. So anytime you're doing a connect and an on resume, make sure you're also disconnecting. If not, you will inadvertently possibly consume a lot of power by continuing to request location updates when you shouldn't be. So what I'm going to do is I'm going to override the onPause method. If you remember from this hierarchy, the onPause method. So I simply type on and then PAU. Sorry, it appears to be a little bit frozen at the moment. On PAU, and then control space on pause. That will override the on pause method. And in here I can say LocationClient.disconnect. And there we go. So when we exit this screen now, we are disconnecting from the location client. Now remember, we had that onConnected method. That means once the connection is successful, the onConnected method will be invoked. The onConnected method will be invoked. So what we can do in that case is we can finally say, okay, I want to subscribe to locations and I want to send them to a listener. So let me just clean up the comment here, and I'm going to say LocationClient.request location updates. Okay, that's going to require one of our location request objects like we created up above right here. Okay, so we pass in request for that, but the second object it needs is what? The second object it needs is an object that implements the interface LocationListener. So before I finish off this line, and I'll tell you what, I'll go ahead and put a semicolon, but you see it's redlining currently. You see we're currently getting a red line. Before I finish that up, what I need to do is add yet another interface to this class, and that interface is going to be LocationListener. If you've done any work with GPS before, and Control-Shift-O to implement that interface, this will sound fairly familiar. So request, and then we'll put in this, the current object, and save, and we see now that the location client request location updates properly compiles. We do have one more thing we want to take care of. Because we implement this LocationListener interface, we have to also implement any methods that interface specifies. And you see, once again, you've probably seen me do this a few times in this video. Once again, map of plants is redlining because it does not implement those methods. Okay, and it will tell you here, the type map of plants must implement the inherited abstract method LocationListener on location changed. And that's good. This is a very important method. So I'm going to say add unimplemented methods. And what we're going to see is now we're going to get this on location change. Now this is probably the most important method of all of the methods that we have looked at in this video. Why? Because look at the parameter. It's receiving a location object. So let's just see what's going to happen here. I'm going to say location.getLatitude, location.getLongitude. Okay, I'm going to control 1. Assign to new local variable. Longitude is fine. I'm going to control 1. Assign to new local variable. And latitude is fine. Okay, now what I'm going to do, I'm going to move this over so we can see it. I'm going to add line numbers. And I'm also going to toggle a breakpoint. Okay, so we're going to say show line numbers. Okay, so this is line 88 and 89. I'm going to click on line 89, which is a little hard to see over this warning here, but we see that line breakpoint has been set. So what we're going to do now is I'm going to save this. I'm going to deploy it to an emulator, and we're going to run. We're going to use the DDMS to send a latitude and longitude coordinate up, and we're going to watch. We're going to notice that on location changed will be invoked when we send that latitude and longitude up. Okay, now raising the emulator sometimes takes just a couple minutes, so I'm going to go ahead and pause the video and I will restart it as soon as the emulator is up. And now the emulator is up. So I'm going to click and choose map. It will take just a moment to render this. While that's rendering, I'm going to go over and, okay, it didn't take too long, I actually did it. I'm going to go over to the DDMS in Eclipse, and we see I have my location. I kept trying to get this right on, Peterborough, Huntingdon, Cambridge, that area in the UK. We'll try a little bit better this time. So what I'm going to do now is I'm going to choose send. I do have this running in the debugger. So I'm going to choose send. And if all works well, sure enough, there we go, our notification that we're toggling over to the debugger. And now take a look. What it's noticed is it's noticed that our location has changed. It's noticed that our location has changed. It's come to the onLocationChanged method, and now it's gathering the latitude, okay, 54.42, and also the longitude, minus 1584095, which is the coordinates that I set in earlier. I'm going to go ahead and choose play and let this continue. Now I'm going to hit the My Location button. And gosh, I'm getting a little bit closer. At least at this point, I'm on mainland England. So we'll go ahead and wrap up this video. In this video, we've seen how to use several things. Oh, I'm getting really close, actually. Okay. We've seen how to use several things together to acquire location data. We've seen that we can use the LocationRequest to set parameters on how frequently we want to receive updates. We can use the LocationListener in its onLocationChanged method to actually receive latitude and longitude when it changes. And most importantly is this part, line number 77, where we use the LocationClient to tie together the request and the LocationListener. We also know that we typically want to connect the LocationClient in an onResume method, but even more importantly, we need to disconnect in an onPause method to ensure that we're not using too much memory, too much battery life, because that will count against us. So that's what we look at in this video. In the next video, we're going to look at actually parsing JSON by triggering an event to occur from this onLocation change. So when the location changes, we're going to go out, use the latitude and longitude, okay, to request a list of plants that are nearby. We see we have this URL right here, plantplaces.com/Perl/mobile. Use specimen JSON PL latitude and longitude. What we're going to do is we're going to use this onLocationChanged method to populate the latitude and the longitude, and then we're going to get back results like this. We'll parse those results into a set of objects. We'll make markers out of those objects, and we're going to throw those markers right onto our screen. So I look forward to seeing you in that video. This is part 3 so far. Looks like we'll have at least a part 2, possibly also a part 5. Thank you.